The first question in this tutorial deals with the exponential law that says a to the power of negative m equals 1 over a to the m. In other words, when we have a negative power, we can use this law to make the power positive. Let's look at a. So here we have x to the negative 1. We can apply this law, and it's going to be 1 over x to the positive 1, or just 1 over x. Going to b, we have p to the negative 2. We can write it as 1 over p to the positive 2, or 1 over p squared. In c, we have 2y to the negative 3. Applying this law, we can write it as 1 over 2y to the positive 3. Now, remember that when we have brackets, we multiply the powers. The 2 here has a power of 1 that we don't write, and so does the y. So then, multiplying the powers, so 2 to the 1 all cubed will be 2 to the 1 times 3. So 2 cubed, and then y cubed. And of course, we can simplify this even further. 2 cubed is 8, so we have 1 over 8y cubed. Let's look at d. We can first get rid of the negative power by using this law. So let's do that. So this is going to be 1 over all of 27 x to the 6th y cubed, then all to the power of positive 1/3. We can simplify further. We're going to use prime factors of 27. So we know that 27 is 3 cubed. And now, since we have brackets, we multiply the powers. So 3 times a third is 1, so we're left only with 3. 6 times a third is 2, so it's x squared. And 3 times a third here will give us 1, so we'll have y. Let's look at e. We can first make the power positive by using this law. So it's 1 over all of 32 m to the 5 n to the 10. And this is all to the power of positive 2/5. Now we can use prime factors for 32. We know that 32 can be written as 2 to the power 5. We have brackets, and that means we must multiply the powers. So 5 times 2/5 will give us 2, and we'll have 2 as well as a power of m. And then 10 times 2/5 is 4. Now we can simplify further. 2 squared is 4, so it's 4m squared n to the power 4. Then the second question here deals with the exponential law that says a over b to the negative m equals b over a to the m. In other words, when we have a fraction with a negative power, we can invert the fraction and the power becomes positive. So let's look at a. We have p over q to the power of negative 1. Then applying this law, we can invert the fraction, so it becomes q over p, and the power becomes positive. So q over p to the positive 1, and of course we don't have to write the 1. Let's look at b. We can first invert the fraction, so we can write it as y to the 5 over x cubed. And of course, by this law, this power will become positive. So to the power of positive 2. Because we have brackets, we can multiply the powers. So we end up with y to the power of 10 over x to the power 6. We can first invert the fraction to make the power positive. So let's do that. So this is going to be to the power positive 3. Now we have brackets, which means we can multiply the powers inside the brackets by the power outside. So important to note that the 3 here has a power of 1 that we don't write, and so does the 2. So then multiplying the powers, so it's going to be 3 to the 1 to the power 3, so 1 times 3, so 3 cubed, n to the power 4 times 3, 2 to the power 1 times 3, so 2 cubed, and m to the power 3, and we multiply the 3's by each other, so it's going to be m to the 9. We can simplify this further. Of course, 3 cubed is 27, and 2 cubed is 8. Let's look at D. We can first invert the fraction in order to make the power positive. So let's do that. So it's going to be to the power positive 1 over 3. Now we can use prime factors for 125. So we know that 125 can be written as 5 cubed. We can also use prime factors for 27, so that's 3 cubed. And now we can multiply the powers because we have brackets. So 3 times the third is 1. So 5 to the power 1. Then 9 times the third is 3. 3 times the third is 1, so it's just 3 to the 1, or 3. And 3 times the third is 1, so it's 3a. We can start by inverting the fraction, so the power can become positive. So this is going to be to the power positive 4 over 3. Now we can use prime factors for 8, so 8 is 2 cubed. And since we have brackets, we can multiply the powers. So 3 times 4 over 3 will give us 4. So we have 2 to the 4 over, and here we also multiply the powers. 3 times 4 over 3 is 4. So 2 to the 4 over a to the 4. Then finally, 2 to the 4 is 16. So we end up with 16 over a to the power of 4. Then question 3 here deals with the exponential law that says the nth root of a equals a to the 1 over n. In other words, when we have a surd, we can use this law to write it in exponential form. So let's look at a. We have the cube root of x. So in this case, n is equal to 3, and applying this law, it's going to be x to the 1 over 3. Let's look at b. Here we have the square root of p. Now, what's important to note, when we have a square root, there's a 2 here that we don't write. So then, applying this law, n is equal to 2, so this is going to be p to the 1 over 2. Let's look at c. we have the fifth root of y. So n is equal to 5 here, and applying this law, it's going to be y to the 1 over 5. Then question 4 here deals with the exponential law that says the nth root of a to the m equals a to the m over n. Once again, we can use this law to write a surd as an exponent. So let's look at a. We have the cube root of x to the 6. So in this case, n is equal to 3 and m is equal to 6. So using this law, it's going to be x to the 6 over 3. In other words, x squared. Let's look at b. We have the cube root of m to the 8. Once again, when we have a square root, we need to know that there's a 2 here that we don't write. So here n is equal to 2 and m is equal to 8. So then applying this law, it's going to be m to the 8 over 2. In other words, m to the power of 4. Let's look at c. We have the cube root of 64, m to the 12, n to the power of 9. Here we're first going to use prime factors for 64. So we know that 64 is 2 to the power of 6. Then in applying this law, we can divide all of the powers under the cube root by 3. So it's going to be 2 to the 6 over 3, m to the 12 over 3, and n to the 9 over 3. We can simplify this. 6 divided by 3 is 2. 12 divided by 3 is 4. So m to the 4. And 9 divided by 3 is 3. Then finally, 2 squared is 4. So it's 4 m to the power 4 n cubed. Let's look at d. Once again, when we have a square root, we need to realize there's a 2 here that we don't write. We're going to find the prime factors of 256, because we don't have to write a 2 here. We know that 256 is 2 to the power of 8. Since we have a 2 here, we can divide all the powers under the square root by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. And of course, we don't have to write the 1. So just Q. We can simplify this further. 2 to the power of 4 is 16. So it's 16p squared Q. Let's look at E. So we have the fourth root of 81a to the 4, b. We're first going to find prime factors of 81. We know that 81 can be written as 3 to the power 4. Now, important to note, the b has a power of 1 that we don't write. So, applying this law, we can divide all the powers under the root, under the fourth root. All the powers we can divide by 4. So it's going to be 3 to the power of 4 divided by 4, which is 1. So 3 to the 1, or just 3. 4 divided by 4 here is 1, so we get a to the 1, or just a. And then b to the 1 divided by 4. So b to the quarter to the power of a quarter. Then the last question in this tutorial deals with exponential law that says a to the power 0 equals 1. In other words, any number or anything to the power of 0 will be 1. So let's look at a. Now, the brackets here means that everything inside the brackets must be raised to the power 0. And we know anything to the power 0 is 1. So the answer here will be 1. Let's look at b. There are no brackets here, so only the y must be raised to the power 0. So we have 3, and y to the power 0 is 1. So 3 times 1, which is equal to 3. Then c, 1000x to the 6th y cubed, all to the power 0. Once again, everything inside the brackets must be raised to the power 0. And we know that anything raised to the power 0 is 1. So the answer for c will also be 1.